We're working on activity 2 on page 279 through 282. And we're working on a topic called point slope form. So to revisit the last video, we were working on slope intercept form, right? We can use that form when we're given the slope and the y-intercept. The thing is, every single time we're not always going to be, we're going to be given some other different information. So here it says, right, we can write in slope intercept form, but in general, to write a linear equation, you need either a slope and a point or 2 points. So the form that we use is we're going to be given 1 point and the slope of some linear relationship. You can write an equation with that. The thing is, we use something else besides y equal to mx plus b. I'm not going to go through the worked example, but I just wanted to highlight some key things here. So the prompt, it says you can use the slope formula to write an equation given the slope and any point. And we have the point here as 2, 6 and the slope as -1/2, right? You plug that into this formula, which, right, we're familiar with, right? We plug in y2, y1, x2, x1. Anyways, so it goes through this kind of long process here. That process is not super important, but I do want to highlight this, is that you get this equation. Y equal to -6 equal to, or sorry, y minus 6 equal to -1/2 times x minus 2. So that's somewhat complex, but we're going to make kind of sense of this because typically we wouldn't really go this route using point slope form. We'll come back to that. Here, we're given this long equation or longer equation. This is the equation for point slope form. Right, point slope form. When we're given a point, x1, y1, and we're given a slope, m. And you plug it into this, so it's y minus, you'll plug in for y1 equal to m times x minus x1. What I highlighted in blue, these are the values that we're going to plug in a number instead of a variable. Everything that I did not highlight, that's just a part of the formula that we, it's just part of the structure of the equation. What's above it, I'm not going to go through this, but if you want to know, like, how do we get this formula, really, it's using the slope formula, and you're multiplying both sides by our denominator. It's kind of like when we solved an equation. You don't have to write this part, right? You multiply both sides by x2 minus x1. And you can see what happens from here, and then from here to here, we use the distributive property where we multiply. Okay. Anyways, in case you wanted to know where this formula comes from. But we're going to get to this last part here. Number 1, it says rewrite this form or this equation in slope intercept form. So let me rewrite this so that we have some space to perform some kind of computation. Now this needs to look like this, y equal to mx plus b. So we have to simplify some things so that it's in that form so we can figure out what is the slope and what is the intercept. What we have here on the right side of the equal sign is, right, distributive property. We're going to multiply. So distributive property you typically learn in Math 6, but let's revisit this. I'm going to rewrite y minus 6 equal to, and distributive property you multiply. We're going to multiply -2 times x, or sorry, -1/2 times x. That's -1/2 x. And then you multiply -1/2 times a -2. Well, a negative times a negative is a positive. And what's half of 2? Right, half of 2 is 1. So this looks closer to being slope intercept form off to the right. But notice how we have y on the left side. We do not have just y on the left side. We have this -6. All right, we can use what we've learned in, previously in solving equations to get rid of this -6. We're going to add 6 to both sides. We're going to perform an inverse operation. I'll write this underneath a +1 because those are what we call our like terms. So the final equation here is y equal to -1/2 x plus 7. And this is something that we can then graph, right? The y-intercept is 7, the slope is -1/2. We can find the rise and run from that. But let's continue this on the next page, still continuing activity 2 on page 280. Okay. So what it's having us do here, it's having us use that same formula or equation. And it says identify and plot the point given from the form. I'm going to quickly go to the previous page. So this equation, we have this point, 2, 6. And we have the slope, -1/2. So let's graph that. 2, 6. That's 2 to the right, 6 up. Let's put a point right here. This isn't on the y-intercept, but we can still graph this because we're given a slope of -1/2. I'll put -1/2. That's a rise of 1, so that means I'll go down 1 and right 2. So that means I'd go right here. We can continue this pattern, so keep going down 1, right 2. And then I'm also going to go in the opposite direction. I'm going to go up 1 and left 2 to continue this linear path like this. Let's connect it and then extend through. Okay. And the reason I wanted to graph this is so that we can compare this to what we did on the previous page, right? The equation that we got, y equal to -1/2 x plus 7. That plus 7, where does that play in here? The plus 7 is the y-intercept, and notice how that crosses the y-axis at +7. Okay, and then from there we would move down 1, right 2. Anyway, so for the most part, exactly the same how we graph, minus where we begin. Okay. All right, so leaving that behind, let's go to number 3. I'm going to do number 3 and 5. And it says, write the equation for each linear relationship in point-slope form. Now, above this, I wrote point-slope form, right? I know it's a complex formula because there's a lot of operations and variables, but we're going to try to make this as simple as possible. What I have in color are the things I'm going to replace with numbers, and those numbers are going to be given to us, at least for number 3. We're going to rewrite everything else, though, okay? So the first example, or first part of this, I'm going to put y minus, and I'm going to replace it with y1. Now looking at our information, it says the slope is -8, so that's m. And the point 312 lies in the line. So the point 3, that's x1, and 12 is y1, right? It's always x and y, and we're putting 1s here because it's the first point. Anyways, so y1, that's 12. Equal to m, right? M is -8. And then parentheses, x minus x1. x1 is, right, look at the ordered pair, it's 3. So this, although complex, this is an equation that we can then try to convert or graph in point-slope form. Okay, but for right now, we're just going to keep it simple. We're just writing the equation. We're not doing anything else besides that. Okay. All right, you're welcome to do number 4 and 6 as you do, but I'm going to go to number 5 because I want to give you a context and how that plays into point-slope form. Okay, so number 5, it says it costs $1.10 per pound plus basic shipping charge to mail a package. And then the other piece of information, it says a 10-pound package costs $14 to mail. We want to convert this to what the information we have for number 3. So this second sentence, that gives us an ordered pair. 10 pounds, it's going to cost us $14. So that's 10, 14. So that's going to be my x1, y1. And when we think of rate of change, right, the rate of change is how much something is increasing or decreasing. That's what the slope represents, right? So we would say m is this 10 or $1.10. I'm going to put 1.1. Okay. After we identify these pieces of information, then this becomes a problem like number 3. So I'm going to rewrite this. You can look at the formula here, or if you want, you can rewrite this, but I'm just going to plug it in. So this would be y minus y1 is 14 equal to m is 1.1 times x minus x1. x1 is 10. All right, so that's the equation in point-slope form. Okay, moving on. So pause at this point if you want to check your work on those problems, but let's go to 281. We're skipping 7 and 8. We're going to go right to number 9. 9A, and I'll leave 9B as a you do. So number 9. Identify the slope and a point on the line from the given equation. We're already given it, we don't have to write it. Then graph each line. Be careful to take into account the scales on the axis, right? Are they going by ones? And the signs of the points given in the equation. Okay, so it might be helpful to rewrite this again, or you could just look at what you've already written in the previous page, but at least for my purposes, I'm just gonna keep it here, okay? So we gotta figure out, we know, we can find a couple of things here, right? We can find our slope. Our slope is what's in front of the parentheses, so m is 1/2, 1/2. But x1, y1, right? Just keep in mind here, a part of the formula, it's always a minus in the formula. So, like let's go back actually. So notice how this was a 14 right here, but when I plugged it in, it's not a positive 14, it looks like it's a minus 14. So you can think of this as like the opposite sign if you don't have a minus there. Anyways, so right here, you could rewrite this as y minus -8, because negative times negative equals a positive. So that y1 is going to be -8. Similarly, for the x's, this could be x minus -6 to equal this positive 6. So x1 is going to be a -6. So the ordered pair we have to start with our x's, -6, -8. All right, let's graph that first. It looks like our axes are going by increments of 1, so that's fine. -6, -8, we're going to go 6 left, 8 down. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Down. All right, and then also to get this line, we'll move for our slope, 1/2. That's up 1, right 2. So up 1, right 2. Let's just continue the pattern. And after you have enough points, we can draw the line and extend it. Connect and extend to the boundary of the graph. All right. So try to replicate what we did for number 9A for number 9B. But let's do a tiny bit more and then we'll call it for this video. So we're going to end it on page 282. I'm going to go over number 10 and we'll leave number 11 as you do. But now we have a context here, right? So the context is we're going to write this in point slope form, and we're going to highlight the important information, and then we're also going to graph this as well. So as best as we can, try to graph it. So the context here, it says a jazz band sells tickets to raise money for a new music stand. They each had some money in their account when they started selling tickets at $5 each. And after selling 3 tickets, the band had a total of $50 in their account. So I've already kind of preemptively wrote some information. Our slope is 5 because that's how much that's our rate of change. And for this, we have an ordered pair, and that is a distinct moment in this context. Right, 3 tickets, $50. Right, tickets is independent. Dollars depends on how many tickets we sell, so that's dependent. Okay. So it says for number 10, let X represent number of tickets sold. Y is an amount raised. Write an equation point slope form. So this would be Y minus Y1 is 50 equal to M, which is 5, and then X minus X1, which is 3. Okay, I know I went kind of fast through that, but if you need to rewrite the formula, you can. All right, and then from here, let's graph this information. Before I begin though, let's actually make 5 into a fraction by putting it over 1. And I want to find where is 350 on here. Okay, 350. So 3 to the right, that's right here, and 50 up, 40, that might be 45. This is 50 here. So this is the point 350. Okay, and we're gonna go up 5, right 1 for our slope. So up 5, it looks like we're going by increments of, are we going by increments of 5? So this is 25, 30, 35, 40, 45, 50. Yeah, so the y-axis is going by increments of 5. They should have a double line break right here because they do skip. Anyways, so up 5, right 1 looks like this. All right, it's kind of on a diagonal opposite vertex of this square in the grid. So just continue that perfectly diagonal line. I think we have enough points to kind of draw this. And I'll extend out this way. You're welcome to use a straight edge or just continue the points. All right, so this is a line that represents the situation. So this, right, the line is helpful because then we can think of, right, how many tickets we need to sell in order to raise a certain amount of money. This part you don't have to write, but like hypothetically, let's say I wanted to know how much it would take for us to reach $100. Well, if I went to 100 to the graph, and then from there went down, right, this tells us we got to sell, well, one more than 12, so 13 tickets in order to get $100. So that's that helps us in order to determine, you know, goals and plan. Anyways, we're done with this context. I'll have you work on this other one, and that's going to conclude this video, ending on activity 2.